Hello, my dear friends, channel members, subscribers of the GMAT 41's channel. I'm saying welcome to you guys, all right? Welcome to the GMAT 41's live class. As we know, we are in the celebration period for which the GMAT 41 has decided to dedicate some days to celebrating you wonderful friends, who have become family on this channel, GMAT 41. As an expression of my appreciation for the wonderful support from you loving subscribers, of course, we are on day 2 of our great achievement, all right? A family of 7,000 plus now on this wonderful channel, committed to giving the best to students at any time in order to continue to drive our dear scholars into excellence in their academic works. So once again, I'm saying welcome to you. Always stay tuned, follow up with this moment of celebration, because on the last day of this celebration, as I proceed in this, of course, something cool is going to go out to someone. Yeah, it's going to go out to someone. So in day 2 of our celebration, the GMAT 41 once again wants to appreciate you friends, with applause for all of your support to this channel. And then to our dear friends in Unizik, in different universities in Nigeria, UniJOS, UniMade, Uniport, Ross, River State University of Science and Technology, mention them, University of Taraba, COOU in Anambra State, as Chukwu Emeka Odumegwu Ojukwu University, and of course our dear friends that connect to our class from other parts of the world, from India, from Ghana, from US, from UK. Thank you all for supporting this channel. Once again, your presence here continue to drive this channel from height to height, okay? And of course, we wouldn't forget to give the greatest thanks to our God and helper, Jehovah, for all of his support, the strength he gives to the GMAT 41, and of course, the wisdom to continue to deliver non-stop. As I celebrate this day 2, I've got something for you, friends. I want to expose a super secret, all right? It's going to be a boom as I expose this super shortcut with respect to some questions on differentiation. This semester, different schools operating on second semester will be taking this topic and, of course, this course, okay, for those offering mathematics, in their departmental work. I know of Unizik, I know of other universities as well too that are taking this Math 102 this semester, all right? And of course, they're going to deal with this part of differentiation. So this is what I want us to do as we celebrate this day 2 of our great achievement and defeat that the GMAT 41 has attained. We are going to look at differentiation of implicit function and functions of the form f of x to the power of g of x. What I intend to do in this class, all right, as I celebrate you, dear friends, is to put you through what your lecturers are going to teach you, what you're going to learn from textbooks, and of course, expose you to this super shortcut that you need when you are seated in examination hall. You may not see this, all right, in your lecture hall. Generally, it's possible you may not see it. Since some years now, in 2020, I devised, that is 2020, I devised this means when I also worked on a particular formula that can be used to obtain the value of tension. I actually exposed that last semester to you, dear student, how to obtain tension for a tightrope walker. So on the same day, I think that was around December 2020, I had also come up with this formula, which I call the Omakas del F formula we're going to use in solving this same problem, as you might see being taught in your lecture hall. All right, so I've got this question and we are going to see what to do here. we're going to see what to do here. And let's see the question we have. Let's see the question you have. Please, once you connect to this class, you know, as usual, please share the link to your departmental WhatsApp group, share it to your friends and invite them to come. With me here, I've got these questions. Now, these two questions we're going to solve based on differentiation of implicit function. By the way, implicit function is type 2 function whenever you are dealing with differentiation. We have that which we call explicit function, where y is equal to f of x. That's to say that y depends on x and x only as a variable. This is explicit function, explicit function. And then we have that in which y depends on x and then on y again. That is to say, you have the dependent variable, and the dependent variable depends on two or more functions, right? And now in this case, we refer to this as implicit function, implicit function. So if you look at these two functions, you see the clear difference. The dependent variable y here depends on x. But in this case, the dependent variable y depends on more than one variable here. It depends on x and as well depends on y. So this type of function, we call it implicit function, and we have this special way of differentiating it. However, like I had stated in my key lecture videos where I taught differentiation, and of course to our dear students in Unizik who attends the GMAT 41's physical tutorial on campus, I'd always say, and I continue to beg you, dear friends, if you are learning differentiation, one of the most important things you want to give 99% attention to is standard derivatives. There are about 17 functions whose standard derivatives you are meant to know. So you are expected to memorize those standard derivatives, and then from there, everything will fall into place. If you do not, then there will be problems in understanding differentiation. So you see, like I said, this is celebration day 2. It's my duty in this day 2 celebration to expose the secret of these. Yes, today, later this evening, September 4, the GMAT 41 will be holding GMAT 41's physical tutorial on campus in Unizik. You're invited, okay, to join the GMAT 41's tutorial. For those of you that wish to attend physical tutorial, identify with GMAT 41, and you learn even more, all right? But on this channel also, of course, you know, there is no going back. I'll continue to hit this hard for you and breaking down this concept. At least I've been able to expose the concept of explicit and implicit function. Most of you are used to this explicit function because usually the dependent variable is given and it depends on just one variable. You'll be seeing something like x and x and x and a. But what if you see a mixture of x and y? How do you deal with it? Like I said, because we are in the celebration mood, I'm going to pick this question. This question I have here is extracted from Unizik, you know, a previous exam question. And we have this. The question goes this way. Let's see. If that's question 1, question number 1. Remember what I said? I'm going to solve this the way you will see it in class. And then we'll now look at the way you are actually meant to deal with it if you meet this in exam. If 2y cubed minus x squared is equal to 4xy, then dy dx is what? Then dy dx is, we don't know. We have options here, although let me see how far I can copy out the options. Option A is 2y plus x, and then over 3y squared minus 2x. And then option B is y plus x over 3y squared minus 2x. And then we have option C. Option C to be y minus x, and then over 3y squared minus 2x. We have option D giving us 2y minus x, and then over 3y squared plus 2x. Then, of course, the option E, which goes with none of the above. Option E, which goes with none of the above. So how do we solve this problem? We're going to look at the general method. Yeah, if you're learning differentiation, what you're going to be put through. And that's what you're going to see in your lecture hall. Okay, now if you look at this function, This function is implicit function because you can see that x and y are more involved. This function is not written in such a way that y is equal to something that contains x. No, it is written in such a way that you see y appearing more than once. And again, you even observe, let us assume that y appeared only once. Let's assume. You will notice somewhere, like if you have this y and this y is raised to power 3, which simply tells us that this is not implicit. This is not explicit, rather. Because for explicit, y should only be 1, and that y will be made subject to the formula equal to something that contains x. That's how you know that this function is explicit. Anything apart from that is implicit. In that explicit, y is only 1, and the power of y there will be 1, equal to something else that contains x. But you see, that is different in this case. X and y are much more involved here. And again, you can even see that there is a place where the power of y is not 1. So this is an implicit function. So how do we solve this problem? Let us look at the general method 1. I am doing this method 1 so that you can be able to follow through when you see this being done in your lecture hall. And if you are sitting for an examination that is theory, of course, you go with this method usually because your examiner might want to condition you towards that stuff that you were taught. Okay, that you were taught. So let us see how we handle that. Now, the question given to us is 2y cubed minus x squared equal to 4xy. By the general method, you are expected to differentiate this whole function with respect to x. By the way, I don't like the general method anyway. Yeah, I don't like it for students. I think we should go towards a better and faster way of dealing with problems. But all the same, I've told you the reason I am doing this. And I decided to use a comparative approach in this teaching because of the fact that we are in the celebration mood. Day 2 of the celebration. Like I said, always stay tuned. The last day, something is going to go out to someone. Now we have this. So we're going to differentiate this whole term with respect to x. Now, the rule is, if you differentiate y, you are going to multiply your result by dy dx. I was telling my student recently, okay, the physical teacher, I think that was on Saturday, why is it that if somebody gives you y equal to, let's say, 2x squared, immediately before you know you are asked to differentiate this, let's make it 3x squared. And then quickly you just write this as dy dx equal to, then you differentiate here and get 6x squared. From standard derivative, that's how I got to know that this is going to give you 6x squared, okay? I am not in this mood of celebration, particularly to talk about standard derivative. The video lessons are available for you on this channel. You can take it. Besides, if you are joining our physical tutorial, you would also learn. I think today we are having differentiation class also in the evening, like I said, 4 to 6 on campus in Unizik. So the question I'm asking is, where did this dy dx come from? Where? Because before you know anything that happens, that dy dx equal to that. Now I'm going to expose the secret. I'm going to tell you the reason for that, right? The reason is because, see, you are differentiating this whole thing with respect to x. This y alone, y standing alone, if you differentiate y alone, you will get 1. You will get 1. But hey, dear friends, you are differentiating y with respect to another variable, not with respect to y. If I were to differentiate y with respect to y, that will be written as dy dy. That is when you will get 1 exactly as the answer. But in the case where I am differentiating y with respect to another variable, for crying out loud, you have to tell somebody who will come back and read that thing you have done. You have to make the person understand that, see, this variable here is y, but I differentiated it with respect to x, not with respect to y. For that reason, the only way mathematically you can tell someone who comes back later to study what you have solved that you actually differentiated this function with respect to x. The only way you can tell that person, because perhaps you are no longer there to explain it to the person is reading and interpreting it. So mathematics tells us that since we differentiated y with respect to x, differentiating y alone, you get 1. How do you now tell somebody that, hey, this is with respect to x? You will now multiply that 1 by dy dx. The meaning of this differential coefficient dy dx is simple. That I am differentiating y with respect to x. That's the meaning of that. Have you asked yourself this question before? Why is it that if you differentiate that side of x, we don't put dy dx? Why? The reason is because you are differentiating x with respect to x. So in this case, I use the power 3 to multiply the base. So you got 6x, go to the power, subtract 1, using standard derivative power rule. Power rule. Okay? Under that standard derivative, I said there are 17 functions at least you need to learn. So one of it is the power rule function. And so use the power, multiply the base, go to the power, subtract 1, you get this. I didn't multiply here by dy dx. The reason I did not do that is because the variable I differentiated here is x, and I differentiated it with respect to x. So there is no need of putting that dy dx. Now look at this one. If I had something like y squared, because we are going to see it when I differentiate this. If you differentiate that y squared with respect to x, differentiating y alone, you will get 2y. How can you now tell someone that, hey, I differentiated this y squared with respect to x? Then mathematics tells you to multiply this by dy dx. Once someone who understands mathematics sees this immediately, the person knows that you are differentiating with respect to x. So my dear friends, in our celebration mode day 2, the GMAT 41 has been able to explain to you and expose the secret behind all this dy dx you see. So that by the time I use the general method to solve this problem, whenever I differentiate y and I multiply it by dy dx, you won't be confused. Rather, you would say, yes, the GMAT 41's commitment to your academic success is absolute. No going back. It's a total non-stop action. A family and friends of 7,000 plus. We look forward to keep moving. As we hit the tens of thousands, we keep moving, we keep moving. That is the goal. Now, having explained this, that whenever you differentiate any function with respect to x, if you have any other variable which is not x there and you differentiate that variable, please multiply by d something dx, d that variable dx. That helps us to know that you differentiated with respect to x, all the variables you have there. So coming here, I'm going to do that. 2y cubed, differentiate it, you're going to get 6y squared. You're going to get 6y and then squared. I've told you, use power, multiply the base, go to the power and subtract 1. I differentiated y with respect to x. So we shall multiply by dy dx to tell us that, yes, we actually differentiated with respect to x. Come to this, you have minus x squared, differentiate x squared. With respect to x, you simply get 2x. No need of multiplying by dy dx because this is x already and you are differentiating with respect to x. This is going to be equal to, come to this and then differentiate this term. If you look at these two terms, they are being multiplied, 4x. By the way, this 4, we are going to keep it aside. When we differentiate xy, whatever we get, we multiply by the 4. Because the 4 there is a constant coefficient. So I'm going to have 4, then open bracket. This is xy. This is xy. And I want to differentiate x times y. When two variables are multiplied and you want to differentiate it, you use product rule. As a matter of fact, this is one of the reasons why I do not like this general method, especially when the student is seated in the examination hall. Don't worry, the second question we are going to solve, you see that even much more clearly. Why you would have to appreciate the Omakers del F formula, which is a fast shortcut to dealing with this. You're going to see that method too after this question. Why is it I don't like this? In the exam hall, I'm solving this, if it is CBT case, for example, and then I am forced to use product rule to solve this. And even where the thing gets so messy is if you learn product rule in a way that you be doing all this, let u be equal to x, therefore v is equal to y, then you do du dv, du dx, and then do dv dx, then using product rule formula, you're wasting that time. You need to know the interpretation of product rule. And what is it? Keep this first function constant, differentiate the second guy, plus keep the second guy constant, differentiate the first guy. That is the product rule for us. So one doesn't need to go and be stressing himself cramming. Dy dx product rule is equal to u times dv dx plus v times du dx is a waste of time. Here I'm going to keep x constant and then differentiate y. If you differentiate y, you will get 1. Multiply that 1 by dy dx, just like I explained somewhere here. Are you getting me right? Since you are differentiating y with respect to x. So differentiate this y alone, you get 1. 1 times dy dx will give you dy dx. Then plus, remember, in this first term, I kept x constant and differentiated y to get this. Then plus, Reverse the process now by keeping y constant and differentiating x. If you differentiate x alone with respect to x, you are going to get 1. I had said this in one of my videos before. Are you following? If you differentiate any alphabet in its basic form, the form you see it when you are reading your ABCD, your alphabet, you are going to get 1 in that case. So this is going to be times 1, and it's a waste of time writing it. I'll just simply write y there. I've done the differentiation. All I now have to do here is to simplify. Bring all dy dx together, make dy dx subject to the formula, and it's going to be equal to something else, variables that no longer contain dy dx. So let us round off this, because I've exposed the secret here, I've broken it down. Whatever we are doing from here next is just ordinary basic mathematics, simplification. So I shall open up this bracket. This is going to give us 6y squared dy dx, and then minus 2x equal to 4x dy dx, and then plus 4y. I use this 4 to open up the bracket. I hope that part of the board is showing. I'll be showing, So with these, I'll collect like terms, the dy dx term together. Of course, this will move to the left hand side, and then giving us 6y squared dy dx, then minus 4x dy dx equal to 4y. You see, I move this term to the left. So I have 4y now, moving minus 2x to meet it is going to become plus 2x. Factorize the dy dx term here. If you factorize dy dx, the left is 6y squared minus 4x, then that's going to be equal to 4y plus 2x. Make dy dx subject to the formula by dividing both sides of the equation by the coefficient of that dy dx that you want to make subject to the formula. So dy dx will now be equal to, divide here by 6y squared minus 4x. If you divide here by that 6y squared minus 4x, it's going to cancel out. Go to the left hand side, divide 4y plus 2x by 6y squared minus 4x. This is the answer. This is the answer, the dy dx solution of this. The differential coefficient of y with respect to x of this function. The derivative of this function. This is the answer. However, if you look at this question, this answer we have obtained, I believe that it's not here. And the reason is simple. Okay? We are here to still do certain factorization from here. Because if you look at this in the numerator, 2 is common. Pull out the 2. Factorize the 2 from these two terms, you'll be left with 2y plus x. And then this is all over. 2 is common to the denominator. Factorize that 2, you'll be left with 3y squared minus 2x. And then you'll agree with me that the 2 will divide each other, so that in conclusion, therefore, dy dx is equal to 2y plus x all over 3y squared minus 2x. So can we check for the option that has this? If there is no option that is in agreement with what we've obtained here, then the answer will be none of the above, not all. However, if you look at this, I guess option A goes with this particular solution that we've obtained. 2y plus x in the numerator, 2y plus x in the numerator over 3y squared minus 2x over 3y squared minus 2x. Therefore, we conclude that the correct option here is option A. So this is the general method approach to solving this question. I'm going to wipe the board now, and then we shall look at the alternative method, method 2, the Omakars del F formula that can be used to still achieve the same results, but it might interest you that this formula is only going to take you one step, to do the differentiation. But the first and second step, you've gotten your answer. The first step is the differentiation, the second step is just to simplify, and then you get your answer there. So let us see what we've got there. Let's see what we've got there. I'm going to wipe this part of the board. I'm going to wipe it. We'll still maintain the question. So I'll wipe this guy. I'll wipe this guy. Remember, at the end of this live celebration, live Math 102 celebration with you guys, of course, a copy of the video will be made available. So you can still come back and see what I have explained already. Believe me, you will love it. You'll see that all these things, they are 1 plus 1. I'd always say this calculus is very interesting and simple. Forget whatever anybody tells you, trying to intimidate you in calculus. Calculus, like I said, is one of the most interesting and simplest part of mathematics. I shall wipe this part of the board now. Let us look at method 2. Or perhaps as we go to method 2, let me still leave that part. This is method 2. You are using the Omak's del F formula, okay? Using Omak's del F formula. I've used this before. It's there in many of my videos, okay? So it's not something new. It's many years since I've started using this. So what are we expected to do there? As we solve this question, go to that. You are given a function that depends on x and y. You are given a function that depends on x and y. And that function is what? Remember what I said? Move all these things to one side of the equation and make it equal to your function of x and y. This is a function that depends on x and y, which is what we have here. So usually I prefer moving where you have fewer terms to where you have more terms. So I shall move this 4xy to the left, but you can still decide to move the left terms to the right. Okay, the choice is yours. So the function given to us will now be 2y cubed minus x squared. As this 4xy moves, it becomes minus 4xy. All right. Then I shall now use the formula. This time I have to wipe this part of the board. I have to wipe it. So at this point, we are going to apply the formula that dy dx is equal to negative del f del x all over del f del y. This means take partial derivative. You can see that this d is no longer standing straight. Dy dx for total derivative. Rather, this d you are seeing is bent, is a symbol used for partial derivative, and we pronounce it there. So we are going to differentiate this function partially. First, with respect to x for the numerator, and then next with respect to y for the denominator. And you see, whenever you are carrying out partial derivative, is a very sweet differentiation to do. Because if I'm differentiating with respect to x, if I see y, that y will be taken as a pure constant. If I'm differentiating with respect to y, when I see x, that x will be taken as a pure constant. So let us go and see what we have to do here now. Dy dx will now be equal to negative, open bracket. I'll visit this function back and then differentiate with respect to x partially, because that's what the numerator says. Remember the essence of this class, exposing, the trick in implicit function, and of course we have this other form we are going to deal with. It's a way of celebrating day 2 of the GMAETS 41's FEAT, the achievement that we've attained together as families and friends on this wonderful channel. And so the idea, expose it, break it down, make it a boom, a total non-stop action, so that my dear friends will get the 1 + 1 stuff in it. All the details. So let us move on. I'm going to differentiate this function with respect to x partially. Wherever you see y, that y is taken as a pure constant. And if there is no x there multiplying that y becomes 0 if you are differentiating it partially with respect to x. Let's go. This is 2y cubed. I'm differentiating this term partially with respect to x. This is interesting. There is no x here. Automatically, this guy becomes a very pure constant. Just like if somebody gives you a number 2 to differentiate. Just this number, if you're differentiating, you get 0. You know that because it's a pure constant. It doesn't contain the alphabet you are differentiating with respect to. We shall do the same thing here because this y here does not contain x. Therefore, if you differentiate it partially with respect to x, you're going to get 0. Which means that this is going to be 0. I don't need to punish myself writing it. You've heard me say it. If I fix 0 there, and then I differentiate it with 0 minus something, so no need. That 0 goes off. Are you following, right? Come to this minus x squared. Differentiate this minus x squared with respect to x. Remember, that's what you have in the numerator. If you differentiate this minus x squared with respect to x, of course, the 2 multiplies the base, subtract 1 from the power. You're going to get minus 2x. Now we'll move on to this term. And remember, minus 4xy, you are differentiating it with respect to x. Good enough, you have x there. You have x there. So if you are differentiating this term, you won't get 0. So that you would not say, but GMAT, you just said something. When you differentiate y, you get 0. And there is y here, so won't you get 0? No. What you are differentiating here is, you are differentiating with respect to x. And there is x here, multiplying this for y. So what you do is you keep 4y as a pure constant there and differentiate only the x. Anything you get, multiply it by the 4y. Are you getting me right? That's how it's been done. Because the variable you are differentiating with respect to is there, which is x. So here we shall keep minus 4y constant, differentiate x. If you differentiate x, you get 1. 1 times minus 4y will give us minus 4y. Minus 4y. Okay? So we are done differentiating this function with respect to x. We shall now divide it by, differentiate that same function partially with respect to y. We have done it with respect to x first. The denominator says we should differentiate that same function with respect to y. So go back and repeat the same thing respecting y. Come over here now, you are differentiating with respect to y. And good enough, this is y. So you can differentiate it. If you differentiate this term, you're going to get 6y squared. 6y squared. Somebody can now wonder, okay, GMAT, why not we multiply this by dy dx? Since I said in the general method, remember method 1, that if you differentiate y with respect to x, you multiply it by dy dx. Now, dy dx multiplying any derivative of y in this Omak's del f formula does not work out. We don't do that here. The reason, I even explained it when I was breaking down that method 1. You are differentiating the function with respect to y. So this y here we are differentiating is still with respect to what? Y. So if I differentiate and get 6y squared, no need of multiplying by dy dx, because I differentiated that variable with respect to itself. Okay, so that is why we have just 6y squared, and this is one reason I love this method, okay, that I tried to work out some years back. Come over here, this is minus x squared, differentiate it with respect to y. Once again, there is no y here. There is no y here, so this is a very pure constant. If you differentiate that x squared with respect to y, you get 0 since there is no y there. So we throw it off, nothing to be written there. Come over here, you have minus 4xy. You are differentiating it partially with respect to y. Interestingly, there is a y term multiplying that variable you have there. So what do? This minus 4x will now be a constant, and then you differentiate that y alone with respect to y. If you differentiate y with respect to y, you will get 1. Multiply that 1 by minus 4x. I repeat that again. Minus 4x, keep it constant. You are differentiating with respect to y, and interestingly, there is y there. So pick that y alone and differentiate it with respect to y. Differentiate y alone with respect to y, you will get 1. Multiply that 1 by minus 4x, that will give us minus 4x. Minus 4x. So, you see, we've done the differentiation, that's it. So just one step, you've gotten your answer. One step, you've gotten your answer. It's just for you to remember that you have to move all the variables to one side and call it the function you want to differentiate. First time derivative, you've gotten your result. So this is what we have here, and then the only thing we can do is just to simplify. You know, this is minus, minus, factorize the minus out. This minus will affect whatever I have inside, and they will change to positive. I hope you know that, right? There's a follow come minus from the formula. Then 2 is common to these two guys. Therefore, our dy dx will now be equal to, pull out that 2, the 2 comes out, you are left with x, you are left with plus y, right? Plus 2y rather. And then divide by, pull out 2 from here, the 2 comes out, you are left with 3y squared minus 2x. And then, of course, you see that this 2 and 2 will cancel. Our result is x plus 2y, or 2y plus x is the same thing, which is the numerator you have here, 2y plus x, all over 3y squared minus 2x, which is the denominator you have here. And of course, this is our answer. I have to take my time to explain this. It doesn't take any time. It's just a straightforward stuff, okay? It's just a straightforward stuff. Please, sir, are you trying to say for all y in the question to be multiplied by dy dx? Yes, in the general method. In the general method. Okay, which is what you're going to see in lecture hall. If y is differentiated in that general method, because the rule is that in the general method, you are differentiating all the terms with respect to x. So if you differentiate y anytime, you must multiply it by dy dx. That is the rule in the general method. Chukwu Jeku Ozioma, thank you for your question and thank you for being a channel member. You're welcome to join the GMAETS 41's channel membership. But in the Omakers del F formula method, you have a formula already that tells you to differentiate that function first with respect to x separately and next with respect to y separately. So in that case, whenever you differentiate y in this method 2, you are not multiplying that derivative of y with dy dx. You don't do that because the y in this case here is being differentiated with respect to y again. In the general method, why we multiply derivative of y with dy dx is because y there is differentiated with respect to x. All right, dear friends, we are done with this particular question. We are done with this particular question. I hope you understand what we have there. We shall pick our next question here. We shall pick our next question to see how we differentiate it. Okay, remember, I'm comparing the general method, which you're going to see in your lecture hall, with the Omakers del F formula for implicit function differentiation. And of course, at the end of everything, I put it to you, you would have no choice. You will go for the Omakers del F formula. Yeah, you will go for it, because that's what the GMAETS 41 stands for. I come up with any shortcut anytime. That shortcut is something you can use in all such kind of questions. And of course, it's something that will simplify such kind of problems. So you want to be free to use it. You want to be free to use it. Okay, I'm going to wipe this question now that we are done with it. We'll pick one more question, which is the last question in this case, under this implicit function differentiation. However, dear friends, don't forget, before you withstand differentiation, there is something you must know. Standard derivatives. There are about 17 of them. Okay, 17 of them. You're meant to know that. In the GMAETS 41's key lecture video on differentiation, where all those things were broken down, you know, because we have first principle, we have standard derivative, we have rules of differentiation. We've done that in our online class also. The key lecture videos are available. Become channel member, you get access to all those. In our physical tutorial on Saturday, I just dealt with that, okay? The rules of differentiation, sum and difference rule, product rule, quotient rule, chain rule. And in fact, let me tell you one interesting thing. When I was done teaching them the chain rule, because I'd always said, I don't like chain rule. But one funny thing is that chain rule is the most important rule of differentiation. But we conquer it using the Omakers major-minor differentiation concept. And the students were just amazed. As a matter of fact, when I was doing this comparative stuff, for one question I wanted to use, I used chain rule for, and then used the direct Omakers major-minor approach. During the time I was handling the chain rule, most of the students were already tuning out. Why overstressing ourselves for this or that? But of course, you just need to be good in all these aspects. Nothing is there. What I'm trying to say in essence is whenever I tell you something that you see this, do it this way. Please don't take it for granted. You may not hear it from many people. Okay, so whenever you hear all these secret facts, hold on to it. Now, after rules of differentiation, you now take differentiation of this form. After that, you meet implicit differentiation. After implicit differentiation, we'll talk about the applications of differentiation, and that ends differentiation. But all the key lecture videos, like I said, they are on this channel. You slide through to the GMAETS 41's playlist on this channel. Locate Math 101/Math 102. You know, click on the playlist. It will open. You see the video lessons. Just scroll and then locate differentiation part. The video lessons are already arranged for you, topic by topic. You know, and then in the topic, the way the subtopics are to be linked. So you don't go there and you'll be searching for things anyhow. They are well arranged for you already. Make good use of them. Remember, like I said, the GMAETS 41's platform is a full-blown online school. Yeah, it's a full-blown online school. I've got all these words available for you. So you can come over here, just like you read your textbook. Here you can watch the video lessons, and they would help to explain all these things you're studying, you know, in your key STEM courses, physics, chemistry, math. All right, let's move on to the next question, please. Let's move on to the next question I've got for you guys. Again, still from Unizik, previous exam question. And our dear friends from other schools, remember, you are free to also send your questions across. Okay, we have WhatsApp group for different schools, and send in, you know, those things you do so that I'll break them down for you. My aim is to see that we contribute our quota to education and make it easy for our scholars to learn and understand. I was once like you, and I know what it means to be a student. It's not easy. It's not easy, but determination is the key. And I'm here for you, dear friends. Let's move on to the next question. This particular question, I think either this exactly or very close to it, appeared in Unizik Math 102 workbook. Yes, and I had solved this something like that, you know, previously, but I was very fast to do, you know, the solving, since it was just to provide the solution to the workbook. Let us see what you're meant to know about that question. The question goes, if exponential 2x plus y is equal to xy, then dy dx, we don't know. Now we have the options. Option A, what have we got there? Okay, y plus exponential 2x plus y, and then divided by exponential 2x plus y, and then plus x. Then option B, we've got y minus 2 exponential 2x plus y, exponential 2x plus y, and then over exponential 2x plus y minus x. Option C, we've got 2y plus exponential 2x plus y, and then all over exponential 2x plus y, and then plus 2x. Then option D, we've got exponential 2x plus y, then plus x, all over y plus exponential 2x plus y. Then, of course, option E, we've got NOTA, whereby you solve and you solve correctly, and none of option A, B, C, and D is the answer. Then, of course, you are left with NOTA. Let us see how we solve this question. Once again, we are going to use the general approach. I am interested in doing this because I want you to follow through as you are being lectured by your lecturers in your various schools. Especially when you get to this part of differentiation, you know, most times students kind of find it technically difficult. So here I'm breaking it down for you. So you smile when this is being done in your lecture halls. You'll be like, yeah, I think I know where my dear lecturer is going to, and you will enjoy the lecture. So from the question we are given exponential 2x plus y to be equal to xy, you know, and so we are going to use the general method, method 1. Method differentiate all this term with respect to what? X. Come to this exponential term. Exponential is also another mathematical function on its own. Among the 17 functions whose standard derivative I have urged you, and I am begging you, please, you're my friends, right? You are my friends, and I want the best for you. And so whenever it is necessary, I beg you, see this thing, you just have to do it. It's not just all about my coming here and then teaching and leaving. I could just come, and then at the end, you're just learning nothing significant. Okay? Or maybe I just say one or two. Please, my aim is to encourage you and tell you to do the right thing that you are meant to do in order to become like me and even better than me. That is what I am looking forward to, so that when I am no longer there, you understand, you people can take it up on. And as you impart this knowledge to others, others can also impart it to others, and it will continue going. Let's help humanity. All right, let's go. So we shall differentiate exponential 2x plus y. It's part of the standard derivative, so make sure you are very well used to the standard derivative. There's 17 of them. Have them at your fingertips. Learn them at heart so that you can quickly say them offhand, even without thinking. What's the derivative of this? You say it without waste of time. So coming over here, we want to differentiate this. So the first thing we have to do is to differentiate this power term, okay, what we have here. And what we have here is 2x plus y. We shall differentiate these 2x with respect to x, differentiate y with respect to x. If I do that, differentiate this 2x, this is going to give us 2 plus differentiate this y, you are going to get dy dx, because if you differentiate y alone, you will get 1 multiplied by dy dx. Now that I've differentiated the argument of this exponential term, argument, what that mathematical function is carrying. It's just like if I have sine 2x, that 2x is the argument of the mathematical function sine. We call it argument. For you to evaluate that mathematical function, you must know what that value is, what that mathematical function is carrying. So in this case, the argument of this exponential is 2x plus y, but don't bother yourself about that. Let's just move on. Differentiate exponential. Now that's the next thing you do. Remember, the first thing we did was to differentiate. I call this the minor function. Yeah, whenever I'm dealing with the major minor stuff, using it to teach. Of course, that's what I do in my most key lecture videos, because that's what students need to really know, understand as they prepare for your exam. I've differentiated the top, the power of this exponential, and I got this. Next, I'll differentiate the main function itself, the major function, which is exponential. From standard derivative, if you differentiate exponential, you will still get exponential. But the mathematical function exponential cannot stand alone like that. It must carry its argument. The argument is the original argument it had from the question, which is 2x plus y. So what have I done here? Differentiate this power. I call it a minor function. It gave us this. Next, differentiate the major, which is the exponential function itself. You still get that exponential. Then write its original minor function, its original argument. We are done differentiating this. This is now going to be equal to, come to this term and differentiate it. Once again, you have x and y being multiplied. And so you've got to differentiate it using product rule, because the x variable and the y variable are being multiplied. But don't forget, you are differentiating with respect to x. I've told you the product rule, clear interpretation. These two guys are being multiplied. You have to differentiate it. Keep this constant, differentiate this, multiply it, plus next, keep this constant, differentiate this, multiply it. So that's the interpretation. We're going to keep x constant and then differentiate this y. If you differentiate y, you will get 1. Multiply it by dy dx, since the derivative is done with respect to x. So you will get dy dx there. Then plus next, keep y constant, differentiate x. If you differentiate x, you are going to get 1. And that 1 multiplied by this y, you kept constant, you will still get y. So no need of showing it. Let us now move on, and then we are going to collect all the dy dx to one side, make dy dx subject to the formula, and that's it. But before we do that, you notice that this will be opened by this exponential term, exponential 2x plus y, and then plus dy dx, we multiply that term, so exponential 2x plus y multiplied by dy dx. And then that's going to be equal to, the right hand side, permit me to write it here, x dy dx, and then plus y. Collecting the dy dx to one side and moving it to the left hand side, I have exponential 2x plus y dy dx, and then this x dy dx is going to be moved to the left, making it minus x dy dx, and then equal to, on the right hand side already you have y, and then this term will also move, making it minus 2 exponential 2x plus y. Good. I just have to move all dy dx to one side. Then every other thing that does not contain dy dx, you move it to the other side of the equation. If you have challenges with basic maths, basic arithmetics, basic simplification, please follow me, follow the GMAETS 41 on GMAETS 41 Basic Class channel. The name of the channel is GMAETS 41 Basic Class. There, is dedicated to scholars in basic level of learning, grade 4, grade 5, grade 6, grade 7, grade 8, grade 9. In Nigeria, here we call it primary 4, primary 5, primary 6, JSS 1, JSS 2, and JSS 3. Because at that level, step by step, I coach them in basic arithmetic works. So you can follow up there. And of course, you have younger ones, you can have them learn from that channel too. So from here, we are making dy dx subject of the formula. If you make dy dx subject of the formula, you factorize it out. Factorizing that dy dx, you'll be left with exponential 2x plus y, then minus x, minus this x. And that's going to be equal to Permit me to fix the equal to here. That's going to be, okay, equal to y minus 2 exponential 2x plus y. I don't like this general method. I don't like it for exam situation, you know. Okay. Princess Adasa, do you handle chemistry too? Yes, and yes, and yes. GMAT 41 focuses on your key science subjects, chemistry, physics, and maths. Full-blown time. Yeah. So I do handle chemistry too. Why not take time to just go through this channel, all right? Go through GMAT 41's channel, especially check the playlist, check the live session. The playlist, especially, you see the wonders, academic wonders on this channel, okay? All right, let's move on. Making dy dx subject of the formula, this is going to be divide both sides by the coefficient of dy dx. So we're dividing the left and right by this exponential 2x plus y minus x. So that's going to give us dy dx as subject to the formula. Of course, if you divide this term by its coefficient, we cancel this bracket. Then the right-hand side, which is y minus 2 exponential 2x plus y, divided by that coefficient of dy dx, which is exponential 2x plus y, then minus x. And of course, this is the solution. No further simplification can be done here. So all we have to do is to go to our options and then check. I'm looking at option B, y minus 2 to exponential 2x plus y, exponential 2x plus y, divided by exponential 2x plus y, exponential 2x plus y, minus, and then x. The correct option is option B. So that is how we solve this problem by the general method. In your Math 102 workbook, for our dear friends in Unizik, all right, see, I'll pray in Unizik, and so I know much about what happens there. I hold my physical tutorial there also, as most of you must have known, all right. Chukwujekozioma, noted, sir, I prefer method 2. I just attempted the method 2 with the examples given in the class, and it was so easy. Thank you so much. I am super glad. You see, it's a thing of joy when I say that the much I am able to give to you, friends, is helping you out. So imagine one of our friends here, she's a channel member, I guess, right? Yeah, a channel member. You see, from the little we are doing in this celebration day 2 on this channel, you see, she has used this to solve the examples she said was given to them or were given to them in class. And it was very easy. She got the answer. So keep it up. That's the spirit. Don't just come here, learn, and that's all. Use what you are learning here to test some things you are being taught from lecture and see how they match. Okay, let's look at method 2. Like I said, I don't like this method 1, this general method. The only thing is we just have to learn it as a general method. But you know, my interest also is targeted towards what you face in your examination. Towards what you face in your what? Examination, because you are working with time and accuracy. So as much as you can use some super shortcut that will still give you the same result, because you're free to do it since you are not showing your workings fully. It's on that theory case that an examiner has the right to enforce a method on you and say, solve this, use this method. And of course, if it is in theory, examiners will usually expect you to use the method that they taught you. Yeah, at least for the last time I checked in lecturing situation. But good enough, I think for Unizik specifically, I know your exam is CBT, so you can do that method 2. Let's deal with the method 2 for this guy. Applying method 2, I'm going to define the function as move everything to one side. So I'm going to have the exponential 2x plus y term. Then I'm moving this xy to that left-hand side. It becomes minus xy. Then remember that to get your dy dx, the formula by the method 2 is minus. You see this thing I wrote earlier, minus del f del x over del f del y. This del, which is partial differentiation symbol, like I told you, you can actually write it this way. Watch, minus f sub x over f sub y. In differentiation, partial differentiation, we use these subscripts to show that you are differentiating partially with respect to that subscript. So this f sub x is the same as del f del x. For you guys that are going to do, for those in Unizik, I know of physical sciences, most of the department that they offer that course, FST, Food Science and Technology, also offer that course, I guess, right? Except I don't know if it had been removed for them last semester or not. But all the same, I'm trying to tell you that this formula you are seeing, this symbol del F del X, can still be represented or replaced rather with F sub X. And then del F del Y is the same as F sub Y. So get used to it. Is that okay? Now, I'm going to wipe here as we now do the differentiation. Remember, at the end of this live class, which of course is celebration day 2 of, the GMAETS 41's FEAT, right? The height we are attaining, because you are GMAETS. So at the end of this live class, a copy of this will be available. If there's anything you did not get, you can come back. At that time, you can control me. You can take me back to here and get a particular concept of what I had explained. So going straight, dy dx is now equal to negative, open bracket. Let's differentiate this function partially with respect to x. And remember what I told you, when you are taking the partial derivative with respect to x, y will be taken as a pure constant. So we come over to this. Again, you're meant to differentiate the argument, which of course I refer to it as the minor function. Why the function itself is the major function. So here I'll pick 2x plus y and differentiate it with respect to x partially. So come to 2x, differentiate with respect to x, you're going to get 2. Then plus go to y, differentiate y partially with respect to x. Now there is no x multiplying this y. So the partial derivative of this y with respect to x will give you 0. Kick it off. Now I am done with that derivative of the minor function. Next, differentiate the major function, which is the exponential. If you differentiate exponential, I told you from the standard, you will still get exponential. Then write the argument that it's carried, which is 2x plus y. Then minus, differentiate xy partially with respect to x, because we are working out the numerator. Since I'm differentiating partially with respect to x, y will be taken as a constant, a pure constant. But take note now that this y is multiplying this x. You are differentiating partially with respect to x, and there is x there. So you differentiate the x alone. Whatever you get, you multiply by the y there. It is just like somebody giving you 5x and say you should differentiate. This 5 will survive. Just differentiate this x alone, you get 1. 1 times 5 will now give you 5. But if I give you 5 alone, standing without x, and I say differentiate with respect to x, since there is no x here, the result is going to be 0. That is why in this case, when you are differentiating, now, when I differentiated this y with respect to x, it became 0 because there is no x multiplying it. But here, when you are differentiating this xy with respect to x, y is there, but it won't be 0 because what you are differentiating, which is x, is there. So all you have to do here is keep y constant. It's going to survive. Differentiate only that x. If you differentiate x alone, you get 1. Multiply that 1 by y. This is going to be times 1. So you are done with the numerator. All over. Go back to the function again and differentiate this time partially with respect to y. Come to this exponential. Pick the minor function, the argument, differentiate it partially with respect to y. This is 2x, kick it off because it's going to go to 0. There is no y there. Come to this, differentiate this y. You are going to get 1 because it differentiated with respect to y. All right. We are done differentiating this, minor function. Next, differentiate the major function, which is exponential. If you differentiate that exponential, you still get the exponential, which of course you are meant to use in multiplying the derivative of that top, okay? The derivative of that minor. 1 times this exponential is that exponential, so no need. I'm taking it off. Come to this, differentiate partially with respect to y. Of course, you know already, you differentiate this y alone, you get 1. Multiply that 1 by x, you get minus x. Therefore, we have done the differentiation. It's just to simplify what we have now. You know that this minus will open up the bracket, thereby changing this sign of 2, which is positive here, to negative, and then changing this negative y to positive y. If you rewrite it, you're going to get y minus, I want to write this positive value first, y minus 2 exponential 2x plus y. Then divide everything by exponential 2x plus y minus x, as usual. And then if you compare this with option B, you'll agree with me that the answer I got using the general method still gave us the same result as using the Omakers del F formula method. So we are done with everything about implicit function. And dear friends, I am telling you today that if you see implicit function anywhere, anytime you are asked to differentiate and you use the Omakers del F formula, you get the result just right there in one step. No time to waste. No time to waste. In your exam, right, questions on differentiation are the simplest to deal with. And of course, your calculus part of this course is the easiest part you can actually attack questions on. That's it. And differentiation and integration. Questions on them are simpler. Very, very simple compared to maybe other topics even. But all said and done, Math 102, in whichever school you are, as long as you undertake with GMAETS 41 and you do the needful. What is the needful? Tune into classes, read your books, go to lectures. So you see how these things match, like I said. Go for your exam and no one would stop your A splashes. You will go in there, get us that A with first class in view. We shall now conclude with functions of this form. Functions of this form. Let's see how far we have spent in the class to see if I am to do that. There is 1 hour and then 2 minutes or so. Yes, we can round it off. You know, you guys are in advanced level. A 2-hour class is not too much for you, friend. But let's see how we can use the next 30 minutes at least to finish up this. I have to also prepare and go for a physical tutorial class. Okay, this is 1:51. I need to leave latest by 2:30, at least to be there to attend to some things before the class kicks off. So we are done with this. Let us now look at functions of the form f of x raised to the power of g of x. So given y to be equal to f of x to the power of g of x, how do we solve this problem? Now I'm going to show you the general approach to it, and of course I'll show you the shortcut also you need to know. The general approach to it is to take the ln of both sides. Okay, so take ln of both sides, you take ln of the left-hand side, because this is actually a special form of logarithmic function. This is logarithmic function, but a special form of it, where the base is a function and the power is what? A function. So take ln of both sides, and I will tell you the reason why you are taking ln of both sides. I'll tell you the reason you are taking ln of both sides. We try to use the knowledge of logarithm so that we can step down this power. And you remember that in logarithm, Math 101 last semester, you treated that. On this channel, you have the video lesson under Math 101/Math 102 playlist on this channel that covers logarithm. So if you have problems with that, you can still on your own make a review. Power law of logarithm, log of a number to a given base, to a given power, the power will multiply the log of that number. So ln is logarithm to base e, natural logarithm. So it shares the same property as log, which means that with this, we can bring this power of this number to multiply this ln. So we now have ln y equal to g of x times ln f of x. Now, if you look at this, you'll agree with me that to differentiate this part, you need to use the knowledge of ln function. To differentiate this part, look at this, g of x times ln f of x. When two independent functions are being multiplied and you are to differentiate, you use product rule. You saw it, you remember, in the questions we just treated, where we had x, y, you differentiate using product rule. So the same thing we do here. Are you following, right? The same thing we do here. Now let's differentiate this ln part. Ln is one mathematical function, a major function among the 17 of the functions which I told you expected to know their standard derivative while you are preparing for differentiation class. So let us see how we differentiate this part. To differentiate this part, you are going to differentiate y. We are differentiating all the terms with respect to x. So differentiate y alone, you get 1 multiplied by dy dx. So you simply have dy dx. You know, in this case, in y is the minor function. So you differentiate the minor function first and then times, go ahead and differentiate the major function, which is ln. Standard derivative of ln is 1 over. 1 over what? Over the minor function, over its argument, over what is in front of that ln. Because, of course, I call this minor function, but purely in mathematics, we call it the argument of this major function ln. So standard derivative of ln is 1 over that minor function, that argument. And so that is now going to be equal to, you have to use product rule to differentiate this right-hand side. You have to use product rule to differentiate that right-hand side. And how do we achieve it? You have keep g of x constant times differentiate with respect to x, whatever that ln of f of x is. Permit me to use another shade of marker. Differentiate with respect to x what your ln of f of x is. Then, of course, you know, you move on to plus. This time around, keep ln f of x constant, and then differentiate with respect to x. I hope this will not cut off. Differentiate with respect to x what your g of x is. Differentiate with respect to x what your g of x is. Let me check that this does not cut off. Let me check that it does not cut off. All right, let's see. Okay, I think it was just affected a little. I can adjust the camera just small. You can just adjust the camera a little so you can see it fully. Good. That's correct. Let's move on. Now I have differentiated this right-hand side. And now you know I'm looking for dy dx. So dy dx will now be equal to get dy dx, you need to remove this over y. And to remove this over y, mathematically, you multiply all the numerator by y. If you multiply all this left-hand side by y, the y will cancel this y. Come to this right-hand side, multiply by y. So this is going to be dy dx equal to y, then times all these things you have on the right-hand side. So that's going to be g of x times differentiate with respect to x what your ln f of x is. So you just have to wait when questions are given to you. You now know what all these guys are, and then you deal with it. Then plus next, keep ln f of x constant, and then differentiate with respect to x what your g of x is. What your g of x is. This is g of x. So this is how you handle the differentiation. In conclusion, therefore, dy dx is equal to the value of y, what y is from the question, which is f of x raised to the power of g of x. You know, that is what y is. Then open all these brackets and copy what is on the board. What is in bracket? Remember, what is in bracket was obtained from the product rule of stepping this power down. Because that's what I'm going to use to show you the shortcut. This is ln f of x. And then plus ln f of x times differentiate with respect to x, whatever g of x is. You see, this thing I showed you, I don't expect you to go cram it just like that. Ln this. No. I've just guided you. Once you are good with your product rule, you don't have problems with this question. You don't. I've just shown you how you derive the shortcut I am going to expose you to. Yeah. All shortcuts I bring out, there are standards, okay? There are rigorous derivation that drives me into bringing it out. So these are firmly established, okay, standard. They are firmly established standards of shortcuts. I don't talk much about shortcuts. I don't want students to feel like there is a fast and hard, you know, just bed of roses all along. So most times I don't talk about it. It's just because this is a celebration day 2 class for the great, greater height that we have attained as GMAETS 41 family, right? And fine. So that's it. When we solve a question on this, you will understand clearly how you deal with this guy. Now, let me give you supposedly what we call the super shortcuts to this. All right. So using method 2, using Omaka's formula, I try to compress this somehow, that if you are given y to be equal to, f of x to the power of g of x, then your dy dx, I hope this has not cut off that side. Let's see. Okay, good. It's still within. Dy dx is now equal to, if you look at, I've derived this stuff. So this is what you need to always remember. Dy dx will be equal to the value of y given, which is the value of y given, or the function that represents y from the question, which is f of x raised to the power of g of x. Then open brackets, product rule on, if you learn this way is best, so that you don't go over stress yourself. Product rule on g of x ln f of x. G of x ln f of x. That is it. So all you now have to do is always remember this. If a question is given to you of this form, where the base is a variable or a function, the power is a variable or a function, variable function, they're the same thing as used here, okay? Once you have something like this, to get your dy dx, first step this power down to multiply the base. And for the power to step down to multiply the base must carry ln. So you now have the power times ln of the base. That gives you two terms being multiplied, two independent functions being multiplied. So your dy dx will now be equal to the value of the y given to you, the original function, the question you're dealing with, times, you now do product rule on that g of x ln of the base. This is what I mean. The product rule even is as simple. See, keep g of x constant, differentiate ln of the base. Look at it. Keep g of x constant, differentiate ln of the base, then plus keep ln of the base constant and then differentiate the power. Keep ln of the base constant and differentiate the power. So when you hear about shortcut, it's not as if there is any other super thing that has been done. These are just the processes of this. Rather than going step by step, can we break it down and then do something better? We've got two questions here we are going to solve. Having given you this, a guideline. So remember this. This and this, they are the same. This is equal to this. All right. So let us pick our first question. Let me write or using the Omaka's formula. Remember, I said these two guys, they are the same. Okay. I have two questions we are going to solve as we close the class today. Let me wipe this. We're going to use the general approach to it, and then, of course, using the Omaka's formula to deal with it. And remember, even this product rule on this, why I wrote it is just for you to see it clearly. Otherwise, like I interpreted finally, the idea is keep the power constant, differentiate ln of the base, plus keep ln of the base constant, differentiate the power of that base. Then do your simplification, multiply it by the original function given to you. All right, so let us see. Today in our physical class, all right, on campus in Unizik, I'll be dealing with implicit function differentiation, of course, application of differentiation in our class today. So question number 1. Obtain the differential coefficient. Obtain the differential coefficient. The differential coefficient of y with respect to x. With respect can be abbreviated as WRT. With respect to x, of x to the power of sine x. Obtain the dy dx of that function there. When you hear differential coefficient of y with respect to x, of a given function is just dy dx they want you to get. So the function given to us is x to the power of sine x. Let's use the general method first. In case your lecturers decide to use the general method to solving this, how do you approach it? So you start by saying that y is equal to x to the power of sine x. That's the function given to us. That's the function given to us. I told you the first thing you have to do is to introduce ln to both sides. So you have something like this. And then this ln of this base to this power is just like having log 5 to the power of 2, say base 10, or base 5. You know, this is going to be 2 times log 5 base 5. The idea is you're using the power to multiply the logarithm. Here, the ln and log, they share the same property. Okay, so this gives us ln y equal to, come over here, you have sine x times ln x. That is super cool. So to get my dy dx, now differentiate the whole thing with respect to x. Come here, differentiate the minor function, the argument, you're going to get 1. Multiply that 1 by dy dx, since you are differentiating this y with respect to x. So we get dy dx. Then next, differentiate the major function ln. If you differentiate ln, you're going to get 1 over what is in front of it. So what I did was just differentiate the minor, differentiate the major, multiply both. And like I've always said in some of my videos and also key lecture videos where I treated all these things step by step, this differentiate minor, differentiate major, multiply is the key interpretation of chain rule. That is why the GMAETS 41 always smile when I say calculus. Even though chain rule is one of the most powerful principles of differentiation, when you come to differentiating something, the major minor classically interprets it. So you can actually do without all this let u be equal to that, therefore dy dx. That is much of what you are going to be taught in your lecture halls. And most times it tunes students off the concept of differentiation and integration calculus. But even with the major minor concept, selecting your let u be this becomes even quite simple. Our key lecture videos deals with all of this. And of course, in our physical tutorial, I've also explained that concept. So this is going to be equal to, come over here, this is sine x, a function on its own, times ln x, another function on its own. Differentiate them using product rule. Simply keep sine x constant, differentiate ln x. If you differentiate ln x, you get 1 over x. Then plus, let me put this in bracket, plus keep ln x constant, differentiate sine x. If you differentiate sine x, you're going to get cos x. Yes, sine is another standard derivative, you know, another function whose standard derivative you're expected to know. It's one among the 17 functions, like I said. So you see, you don't play with standard derivative. I have differentiated this right-hand side, and that's it. It's just to make dy dx subject to the formula now. But to achieve that, dy dx will now be equal to the value of y, you know, multiplied through by y to cancel the y here. The y will now appear on the right-hand side. So that's going to be sine x times 1 will give us sine x all over x. Then ln x times cos x will give us ln x cos x. Ln x cos x. What do you do finally? Dy dx is now equal to, return the value of y. Y is equal to x to the power of sine x. So open bracket, multiply by this term, which is sine x over x. All right, and then plus ln x cos x. And of course, that is the solution. That is the solution. There is nothing we can simplify ordinarily here again. Okay, there is nothing we can simplify normally. Examiners will always leave the answer, you know, in this format. All right, we are moving on. So it's quite simple, nothing is there. But you want to watch out the nature of this function, please. In this case, you have a variable as the base, or a function as the base, and a power, which is also a base. What am I saying? You have a function as the base, and a function as the power. So both sides are functions of variable. That's when you apply this method of differentiation. Okay, so alternatively, we could have gone straight So say you have y to be equal to x to the power of sine x. So dy dx is equal to that value of y given, which is x to the power of sine x. Then the product through differentiation of, sine x ln x. You have sine x times ln x, then differentiate using power. But I told you there is a fast way you can approach that. Instead of even bringing that sine x ln x down, you can differentiate from here straight. Already as I'm teaching you this, you are aware that that power has to come down as a variable. If it is a number that's power, for example, I give you y equal to x raised to power 2x. Sorry, x raised to power 2. Here, the power is not a variable. So if you are differentiating this, you use power rule standard derivative. You use the power to multiply the base, go to the power and subtract 1. Don't confuse this function with this. Don't even confuse that function with a function like this. Let's say 5 raised to power sine x, something like this. This one, the standard derivative dy dx is equal to differentiate sine x, which will give you cos x. Okay, let me say differentiate with respect to x, whatever the minor function is. Because here the minor function is sine x. Then times this whole thing, which is 5 to the power of sine x. Okay, let me use this as a so that I wouldn't... I've already used defined function for it. So let me do the differentiation straight. In this case, here you have your dy dx. The way you handle this, I'm trying to differentiate between functions of this form, and this one. This one we are dealing with, the base is a variable, is a function. The power is a variable, the power is a function. But here, the base is a pure number, a constant number. Because the number here should be greater than or equal to 2. Is a natural number that ranges from 2 above, that kind of function. But look at this one, the base is a function, the variable, and the power is a pure number. The power is any real number in this case. So this function, and this function, they are different. But they look alike if you're not careful. If you've not taken full lecture on differentiation, you might misplace them. Are you following, right? So I am saying that so that you will be careful. You have the key lecture video on this channel that deals with them. Like I say, for our dear Zekites, do you want it physical on campus? The GMAETS 41 puts you through all this. Let me tell you something. There's something many are not aware of. Maybe because of the way I do my things, I always say I'll pray with people who know the importance of seriousness, industriousness, diligence to achieving success. Not someone that thinks that everything will be bed of roses all through. Challenges must come, like I said. We don't decide challenges that come our way, but we have a choice of how we handle those challenges. Now, let me shock some of you now. People who register fully for the GMAETS 41's tutorials, right? Whether physically or online, every month until this happens until July ending, GMAETS 41 supports you for your online access. You know, I am someone of the philosophy of people adopting online form of learning, not just all physical. Yeah. I think the reasons are very clear why everyone should try to adopt online learning. So every month I support our students. The GMAETS 41 support each student on our platform with 2,000 naira to be able to access online works. Yes. So if maybe someone had joined us since May, you can now start counting May, June, July. So GMAETS 41 is giving back each of the students 6,000 naira, right, to support their online studies. That's what this platform is meant for, nothing else. I'm trying to give to humanity the blessing that God has given me in terms of the wisdom. Of course, I've always recognized our God and helper Jehovah for such. So there are wonderful things you benefit from this channel. Wonderful things. Okay, let's round off, please, guys. So like in this case now, the way you differentiate this, all you have to do is differentiate the power, which is the minor function. If you differentiate sine, you get cos x, and then multiply by this whole function, which is 5 to the power of sine x, then conclude with multiply by ln 5. That's how you handle, problems of this kind. So please, my interest, I'm not teaching you this here, neither am I talking of this. This is what we are looking at. But trying to help you differentiate between these three closely related functions. If you are looking at them, you think they are the same thing. Let's go back to this, please. Like I said, you don't even need to punish yourself saying you are bringing sine x down, then ln x, and then using product rule. You can attack this straight. How? Watch. Differentiate the power, keeping ln x constant. Or you can say keep the power constant, differentiate ln of the base. Let's do that. Keep the power constant, which is sine x. Differentiate ln of the base. If I have ln x and you differentiate it, you are going to get 1 over x. Then plus, but you know that what you are doing is product rule. Now reverse the process. This time, keep ln of the base constant. Permit me to write it here. Ln of the base is ln x. Keep it constant. And then differentiate the power. If you differentiate the power, you are going to get cos x. You're going to get cos x. Once again, keep the power constant, differentiate ln of that base, then plus keep ln of the base constant, differentiate the power. So that's just how simple you attack this problem. And in conclusion, our dy dx is now equal to x to the power of sine x, then open bracket, this same thing, sine x times 1 will give you sine x all over x, and then plus, copy out this, which is ln x cos x. Ln x cos x. So we are done with this question, and you can compare it with this step-by-step approach to it. You'll see that you get the same thing. We are concluding with our last question, please. Goodness Leonard, you're welcome to join the GMAETS 41's channel and becoming a channel member. Thank you very much. Thank you for joining the channel, all right? Let's conclude with our last question, please. Let's conclude with our last question. Remember, if you are just joining this class, don't panic. That is one such good thing that technology has done for us. And kudos to YouTube, because honestly, the platform is doing wonders. Yeah, YouTube as a platform is doing wonders. At the end of this live class, which is, a show of celebration day 2 of what we have achieved together as GMAETS 41, a family of 7,000 plus now. At the end of all of this, a copy of this live class will be made available. So you can still check back. Just after the class, you can check back and still retake from beginning all we have done. I'm wiping this so we solve our last question. Our last question here is obtained from Unizik. Previous exam question, question number 2. And here we go. So we have this. Find the derivative of 2x to the power of x minus 1. Then we have the options provided. Option A is 4x to the power of x minus 1. Then open brackets, ln x plus x minus 1 over x. Then option B, we have ln x minus 1, and then over x. We have option C, which is 2x to the power of x minus 1. Then ln x plus x minus 1 over x. Option D, we've got x to the power of x minus 1. Open bracket, ln x minus, open bracket, x minus 1. Then close brackets. I can't see option E here, but it doesn't matter. So that's the question we have, the solution. If you want to use the general method, the choice is yours. Remember, if it is a, let's say, normal class, I just come online to solve this, I wouldn't talk about the general method. I won't. But of course, we are trying to do cross comparison in case you meet any such thing in your lecture hall. Therefore, the GMAETS 41 will be forced to still use the 2 methods to solve this problem. Let's look at the general method, please. Let's look at the general method. So where are we? The question given to us is y equal to 2x to the power of x minus 1. So look at it. So what do you do quickly? Take ln of both sides. You have ln y equal to ln, open bracket, 2x, then to the power of x minus 1. So you want to be very careful here. There is a trap that has been set here. This power x minus 1 is affecting only x. It has nothing to do with these 2. Take note. That is one of the trap that was set here. A student might think that this x minus 1 is affecting this 2x, so that maybe when you are stepping down this and then you say that it's going to affect this 2x. If it were written as this, good. That is when you would say that the power x minus 1 is affecting the 2x together. In this case, the x minus 1 belongs to this x alone. Please take note. So at this point, before we step this guy down, we have to rewrite this as, permit me to put it, implies that this is ln y equal to ln 2, then plus ln. What have I done here? I have distributed this ln and this x. Remember, this 2 and x is 2 times x. Let's go back to addition law of logarithm. Under logarithm, if I give you log a plus log b, in the case where both of them, in fact, let me write it like log 2 plus log x to the power of x minus 1. Because the bases are the same, let me assume that this is base 10, this is base 10. Addition law of logarithm say we should pick one of the log to that common base and then multiply the numbers. The numbers are 2 and x raised to the power of x minus 1. So if you multiply, you get 2x to the power of x minus 1. Do you see this? So we can reverse this arrangement back to addition form using logarithm. And that is what I've done here. 2 times this x. The x has its power on its own. Fine. 2 times this x, distribute the ln to them, introduce plus. It's going to be ln 2 plus ln of x to the power of x minus 1. Are we together, right? So that is how I got this. So that from here, I can now start differentiating. But before differentiating, you have to bring down that power. This gives us ln y equal to ln 2, then plus x minus 1 times ln of the base. Bring this x minus 1 down to multiply ln of the base. Power law of logarithm. It is at this point we can now do our differentiation. So here we differentiate this part with respect to x. Of course, everything with respect to x. We have been doing this ln y. This is simply dy dx times 1 over y. Then equal to differentiate ln 2. Now, take notes. 2 is a pure constant. Ln is a mathematical function. Ln 2 is a pure constant. If you press it in your calculator, you will get a number. Now, there is no variable in that ln 2. No x, no y. There is just ln 2. If you differentiate a pure constant without the alphabet you are differentiating with respect to, you get 0, isn't it? So if I differentiate that ln 2, then I'm going to get 0. Take note of that. Because somebody might think that if you differentiate this, you get 1 over 2. No. There is no x, no variable here. So if you differentiate it, you get what? 0. I've exposed something to you. So this guy goes off if you differentiate. Then come over here and differentiate this term, x minus 1 in bracket times ln x. These are 2 independent functions being multiplied. So to differentiate, you use product rule. Keep x minus 1 constant, differentiate ln x. Differentiate ln x. If you differentiate ln x, you are going. So let's see, the network interfered, and so I have to ensure that everything is okay. Use this to track what is happening at your end. So let me see that the network is back. All right. So let's round off. I was explaining this, the differentiation, we are used to that already. So make dy dx subject to the formula. And then, of course, you have this. I told you that ln 2, if you differentiate it, you get 0 because this is a pure constant. The alphabet you are differentiating with respect to is not there. So if you differentiate ln 2, you get 0, it goes off. Okay, so that's it. We simplified, brought back the value of our y, which is the original function given. So this is what we have. Let's compare it with the options we have here. Let's compare it to the options we have here. Are you following right? As we compare, like I said, it's either we see the answer we obtain in the option or we don't see it. If we don't see it, 2 things are involved. Either there is further simplification required or the answer is simply not there. Is that okay? So let us see what we are going to get We compare. Is there anywhere we have 2x to the power of x minus 1 from beginning? Option C, we've got this. Then as we move in, you have ln x. It doesn't matter. This ln x can come first before this x minus 1 over 2. Addition does not respect order, at least basic arithmetics. 2 plus 5 is the same as 5 plus 2. So having ln x written first before this does not change anything. Good. Option C is the correct answer. Option C is the correct answer. You can see that, okay? So alternatively, going straight, alternatively, we are rounding up. This is our last question, and of course, network, you did well, eh? Network tried today. Let's round off quickly before anything else happens. Alternatively, using the Ohmaka's formula straight, you are given y to be equal to, what do we have there? 2x to the power of x minus 1. And so dy dx is simply equal to, let's do that in one shot. Dy dx will be the function given to you as y, which is 2x to the power of x minus 1. And so what do? You now multiply by, keep the power constant. Keep the power constant. Differentiate ln of the denominator. When you are differentiating ln of the denominator, please watch out something here. Remember, this 2 is a pure number. That is why even when you are doing anything shortcut or whatever, it is still good to have the clear view of the whole thing. If I had not done this thing for you to see clearly that these 2 will disappear, of course, from that right hand side when you are doing the differentiation, what I'm about to explain here, someone might get confused, at least with respect to the first question I solved. You know, because here I am saying that you have to keep x minus 1 constant and then differentiate ln of the base. Sadly for us, the base is 2x. But in this case, we do not handle ln 2x together. You are differentiating. If you differentiate ln 2x, you'll get something off. Wrong. So this is what you want to remember. This is a pure number. For this type of function, keep that pure number away. Keep it away. You have seen it yourself. That is why you see all this shortcut of a thing is a function of something someone had done from the general method. It's not as if there is anything too significant generally. Yeah. Of course, it's good anyway. So these 2, you want to do differentiate ln of the base. Keep the power constant, differentiate ln of the base. Because you have a pure number multiplying, please, that number, kick it off. It has nothing to do with anything here. So you are just taking ln of this variable, ln x. If you differentiate ln x, what are you going to get? Differentiate ln x, you will get 1 over x. So have this in brackets times 1 over x. And then plus, next, we're going to keep ln of that variable in the base. Keep ln of that variable, ln x constant. Then differentiate the power. If you differentiate the power x minus 1, you will get 1. Remember the technicality of what I've done here. Since in the base we have a pure number, you are meant to keep that pure number away. Reason. Ln 2x, if you extract, ln 2x is the same as ln 2x. Normally, because these 2 x's together is the same as ln 2 times ln or plus ln x plus ln x. In this analysis, so ln 2, if you differentiate, you get 0. Then now handle only ln 2x. But if I give you ln 2x straight to even differentiate, how do you even handle it? You still get that 1 over x here if you want to differentiate all of them together. But I'm just saying, don't punish yourself with that too. However, if you want to take ln 2x straight to differentiate, watch, you still get the same result. The minor or the argument is 2x. Differentiate that 2x, you get 2. Then times, differentiate the standard, the major function, which is ln. If you differentiate ln, you get 1 over what is in front. Then these 2 will cancel, leaving you with 1 over x. So if you still want to say ln 2x, differentiate that ln 2x, from your standard derivative knowledge, you still get the same result. So no big deal. Anyway, whether you kick these 2 off or you leave it and still differentiate, you still get the same thing. All right. So having done this, I think we are done. Dy dx will now be equal to the function itself, 2 times x to the power of x minus 1. Then open brackets. You have this and this. this is ln x times 1. This will be x minus 1 over x, then plus ln x. And of course, this becomes our answer. This becomes our answer. All right, this becomes our answer. If you like, you put this x minus 1 in brackets like we have it here. It doesn't matter. But let me show you that this answer can still be written as this answer. I want to play around with this a little. This thing can still be written as or 2x minus 1. Then you work out the LCM of these two guys. The LCM is going to be x minus 1, then plus x ln x, everything divided by this x. You know, this times this will give you x ln x, then x minus 1 plus that x ln x all over x. Then this x and this x, you can simplify them using division law of indices. Using division law of indices, where can I fix that? Where can I fix that? Can I squeeze it somewhere here? You know that this is 2. All of this is in brackets here. This is 2x to the power of x minus 1 times this whole thing. I have a denominator here. This denominator can come under here. Can come under here so that you might be simplifying something like this. So that you might be simplifying something like this. Permit me to wipe this part now. At least you have the question already. So that we can be having something of this form. 2x to the power of x minus 1 all over x, then brackets x minus 1 plus x ln x. Division law of indices. The bases here are the same. So x base, this base x and this base x. The power of this is x minus 1. The power of this is 1. Pick one of the base. So this becomes dy dx equal to, if you pick one of the base there, you are going to get 2, then one of this x. Subtract the power of the denominator from that of the numerator. Since this is power 1, if it goes up, it becomes minus 1. In the power of the numerator, you have x minus 1 already. If you subtract 1 from here, you will get minus 2. Then open bracket, x minus 1 plus x ln x. So these terms, this solution, and this one, they are the same. They are what? The same answer. So your examiner can decide to simplify this further to get this. Whereas in that case, this option will be written in a form where you won't see this denominator again. But then this power minus 1 will change to power minus 2. Wow. It's been a wonderful one, you know. Guys, we've spent close to 2 hours now. This is 1 hour 47 minutes class. And you see, just within 1 hour 47 minutes class, you've learned something wonderful. And this brings us to the end of the GMAETS 41 celebration day 2. Having exposed you, celebrated this day 2 achievement with respect to our becoming a 7,000 plus family and friends on this channel. I've celebrated it with you using the concept of Math 102, breaking the concept of implicit function, and of course, logarithmic functions of this form. I hope you've learned something wonderful that otherwise, maybe it might be tough for you to have gotten from somewhere else. Share the link to this live class to your friends, to your departmental WhatsApp group, to your mates, right? Share it to your neighbor also whom you know are in school. They need this. Become a channel member if you are not yet a channel member. Join on the GMAETS 41's platinum or diamond level. And then, of course, if you want to register fully for the tutorial, you can also contact GMAETS 41. There is a contact on WhatsApp to get information about our full registration package. You can also join our physical tutorial, especially those in Unizik students. Right after now, this is 2:36. We'll be preparing to head to campus, all right, for our physical tutorial. We have still Math 102 in our physical class today. So you are invited to join the class so as to be coached for your A splashes and first class in view. Contact GMAETS 41, you know, on this, and you get information about the venue of our classes and the time. Do have a wonderful day ahead left. Thank you for joining the class.